Chapter 8 is all about trigonometry, and we start out with some similarity in right triangles here. Our first theorem says the altitude to the hypotenuse of a right triangle forms two triangles that are similar to each other and to the original triangle. So if we look at this, we have three triangles formed here. We have this little blue triangle, we have this larger medium-sized green triangle, and then we have the big triangle that we originally started with, which is in red. And those three triangles are similar to each other. And what we're going to be asked to do is to write a similarity statement. And what I like to do, start with the smallest triangle, and I start with the right angle, which is D. Then I go to the short side, cross the short side, which is B, and then I go across the hypotenuse, which is C. So our small blue triangle, the right angle was D, across the smaller side was B, and then across the hypotenuse. Now we do the same thing for the green triangle, the medium-sized triangle. The right angle is D. Then we go across the short side, which is C. And then we go across the hypotenuse, which is A. And now we go to the big red triangle. Starting with the right angle is C. Going across the short side is B. And then going across the hypotenuse is A. And mine are a little bit different than they have. I think they started with the biggest one and went to the smallest one. And you'll see they had A, B, C. And I pretty much had that backwards, A, B, C. So all of mine are opposite of theirs, A, C, D, and then D, B, C. So there are several different ways you can write the proportions or the similarity statements. You just need to make sure that the right angle of the blue one, which is D, matches up with the right angle of the green one, which is D, and that matches up with the right angle of the big one, which is C. So we have two examples here where you're asked to write a similarity statement, and I'm going to color these in again. I'm going to start with my blue triangle. I'm going to go from the right angle across the short side across the hypotenuse. So my first triangle is triangle ZVW. The second triangle, start with my right angle, go across the short side, and then across the hypotenuse. So my medium-sized triangle is ZWU. And then my third triangle, the whole big triangle here, start with a right angle, which is W, across the short side, which is V, across the hypotenuse, which is U. So W, V, U. And example B, start with my small blue triangle. I'm going to start with the right angle. Then I go across the short side, which is L, and then I go across the hypotenuse, which is J. My medium-sized triangle is right here. Start with my right angle, go across the hypotenuse, start with my right angle, go across the short side, go across the hypotenuse. So this is triangle JK. And then the whole big triangle, we start with a right angle, go across the short side, and then the hypotenuse. That is triangle JLK. If you are asked to find the geometric mean of two numbers, you are going to say that x squared equals your first number times your second number. So the geometric mean is your x squared, and that equals the first number times the second number. For example A, then, we want the geometric mean between 4 and 25. We will say x squared equals 4 times 25, which becomes x squared equals 100. And when you take the square root of both sides, I guess I should show that, you end up with x equals 10. Letter B, the geometric mean between 5 and 30. You will have x squared. 5 times 30 is 150. And you are asked to give your answer in simplified radical form. So we will write that square root of 150 as the square root of 25 times the square root of 6. 25 is the biggest perfect square that divides into 150. So when we take the square root of that, then square root of 25 is 5 and square root of 6. So you end up with x equals 5 square root of 6. Letter C, the geometric mean becomes x squared. 36 times 8 is 288. That should be x squared equals 288. To undo that, we square root both sides. The biggest perfect square that divides into 288 is 144 and 2. So I change that 288 to 144 times 2, and then you end up square root of 144 is 12, and you end up with x equals 12 square root of 2. Letter D, to find the geometric mean of 2 and 8, you have x squared equals 2 times 8, which becomes x squared equals 16. Square root both sides, and you end up with x equals 4. The geometric mean of 10 and 30 would be x squared equals 300. 10 times 30 is 300. Square rooting both sides, you have x equals the square root of 300. Square root of 300, I am going to rewrite as square root of 100 times the square root of 3. And now I can take the square root of 100, which is 10 times the square root of 3. And letter F, geometric mean of 8 and 9 becomes x squared equals 8 times 9. That becomes x squared equals 72. And when you take the square root of both sides, I'm going to rewrite that 72 as square root of 36 times the square root of 2. And 36 is now a perfect square, so you end up with 6 times the square root of 2. On the back side, we have another theorem to the geometric means. The length of the altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of the two segments of the hypotenuse. And I'm going to draw a different picture over here. This is my right angle, so that is a right triangle. And this is the altitude. We're going to call that h. We are going to call this little piece x and this piece y. This first theorem right here says the altitude squared, so h squared, equals that left piece times the right piece. So the altitude squared equals x times y. Altitude squared equals x times y. And the second theorem we have, again, I'm going to draw a different picture. And we've got our altitude right here. Let's see, this is x and this is y. This is A and this is B. And we're going to call the length of this entire segment C. And I should draw my right angle in up here. This top left piece squared equals the left piece times the whole thing. So A squared, this top piece squared, equals that piece times the whole thing, x times c. And we have that same relationship on the right hand side, b squared, so this top right piece squared equals the right piece times the whole thing. B squared, top piece squared, equals y times c. This says the exact same thing. The pictures are just in a little different order. And I'm going to start out down here with example D. In example D, we're going to say this height squared equals the left piece times the right piece. So we have 4 squared equals x times 2, which becomes 16 equals 2x. And when you divide both sides by 2, x equals 8. So we just figured out this piece right here. The height squared, altitude squared, equals the left piece times the right piece. Well, if this piece is 8 and this piece is 2, that whole blue segment then is 10. And we need that piece to figure out the y in z. Let's look at the y first. Y squared, top left squared, equals the left piece times the whole thing. So that equals 8 times 10. Y squared equals the square root of 80. And you can either write that as a decimal, or if you would like to simplify your radicals, that becomes square root of 16 times the square root of 5, and your y then equals 4 square root of 5. to figure out z, we do z squared, which is the top right, and that equals the right piece times this whole thing, which is 2 times 10. Top right squared equals the right piece times the whole thing. Well, now we have z squared equals 20. And when you square root both sides, z equals square root of 20. And 20 we can rewrite as the square root of 4 times the square root of 5. And you are left with z equals 2 square root of 5. So we figured out our x, our y, and our z. Now let's go up to example A. Our triangle is kind of turned around in this one, but we're still going to start with this. Height squared equals left piece times the right piece. So that becomes 6 squared equals 9 times x. This height squared, left piece times the right piece. So that becomes 36 equals 9x, and x equals 4. Now, if this piece is 4, this entire distance here, 9 plus 4, is 13. So I'm going to figure out z next. Z squared, notice this piece is on the left. That equals the left-hand piece times the whole thing, equals 9 times 13. 9 times 13 is 117. So z squared equals 117. And if you square root that, you can break that into the square root of 9 times the square root of 13. And when you take the square root of 9, it is 3 square root of 13. And letter y, y squared, notice that's on the right-hand side, equals the right-hand piece times the whole thing, 4 times 13. So we end up with y squared equals 52. And when you take the square root of that, square root of both sides, I'm going to break that 52 into a 4 times 13. And then y ends up being 2 square root of 13. And here's my x, there's my y, there's my z. Letter B, again we start with this one. Height squared equals left piece times the right piece. So to figure out, we're going to figure out this u first. 9 squared equals 3 times u. Altitude squared, piece times piece. So that becomes 81 equals 3u. And when we divide both sides by 3, u equals 27. If that piece is 27, then that entire thing is 30. And now to figure w, we will have w squared equals the 27 times the whole thing, which is 30. So w squared equals 810. And when you square root both sides, 810 will become square root of 81 times the square root of 10. So W is 9 square root of 10. And we also need to figure out the V. V squared, right side squared equals right piece times the whole thing. So that equals 3 times 30. So V squared equals 900. And when you square 900, how about 90? V squared equals 90. And when you square root that, you will write that as the square root of 9 times the square root of 10. So V equals 3 times the square root of 10. Example C, we're going to do this altitude squared. Now rather than left and right, we're at top and bottom. So we will have x squared equals 2 times 10. So x squared equals 20. And when we square root both sides, we end up with the square root of 20. Square root of 20 can be rewritten as the square root of 4 times the square root of 5. So x becomes 2 square root of 5. To figure out z, hang on a second, I'm going to label this whole thing. Whole distance is 12. So z squared equals 2 times 12. Top squared is the top times the whole thing. So z squared is the square root of 24. Rewriting that, we would have square root of 4 times square root of 6, and z equals 2 square root of 6. Y squared, now where the bottom piece squared was the bottom piece times the whole thing. So that becomes y squared equals 120. And I think we would break that into 4 times 30. I guess I should square root both sides here. And then y ends up being 2 square root of 30. I'm going to do letter F next. This one's a little bit different. Letter F, we have to start out with this piece on the right. 8 square root of 2 squared equals the right piece. And I'm going to label this whole segment, this whole thing right here, I'm going to call that W. So that right piece squared, top right squared, equals the right piece times the whole thing, which I call W. We need to square both parts of this. 8 squared is 64. Square root of 2 squared, do it on your calculator if you need to. Square root of 2 squared is 2. 64 times 2 is 128 equals 4W. And when you divide both sides by 4, our W equals 32. Now remember, W was this entire blue length here. So if this whole thing is 32, then when we subtract 4, our X actually is 28. Now we can find our y. Y squared, this is the altitude, that equals 28 times 4. So y squared equals 28 times 4 is 112. And when you square root both sides, all right, I think this is correct, 16 times 7, and the square root of 16 is 4 square root of 7. And the last one then, z squared equals, all right, I just did this one wrong. No, I didn't do that one wrong. Z squared then will equal 28 times the whole thing, which is 32. So z squared equals the square root of 896. And I'm going to leave that one like that because I can't simplify it right now.